The next segment of the product brochure 2014 I want to discuss involves very low power OCXOs. These are usually used in applications that require battery use in the field. So you might have a radio system, for example, a geosensor, a sensor box with a transceiver. This sensor box gets tossed into the ocean, goes to the bottom of the ocean floor, and is a geological sensor for seismic activity, a seismic sensor, if you will. It has a certain battery life associated with the entire module. So low power OCXOs provide the sensor module with accurate timing information. So if you have hundreds of these seismic sensors scattered all over the ocean floor in a given geographic location, when there is a seismic event, all of the sensors will be synchronized to each other within so many parts per billion or so many nanoseconds of time, based on the fact that each has an OCXO reference inside them. So when they're recording their seismic data, everything is time synchronized between all the various sensors in the field. That's one very good application for very low power. What I mean by very low power is an OCXO that'll draw 0.2 or 0.15 watts at 25 degrees after warm-up. All OCXOs, of course, have that initial warm-up period. Traditional OCXOs take sometimes 5 minutes to warm up. Low-power, fast warm-up OCXOs have maximum power of about 0.7 or 0.8 watts, and they warm up in 15 to 30 seconds. The oven current starts to come down quite dramatically until it reaches a steady state of about 0.15 watts for a long term at 25. So applications using battery as the primary source of power, any sort of battery application, they want high performance in their oscillator, but they don't want TCXO type stability. They still want the OCXO type stability. So now there's this niche of products in low power that can satisfy those marketplaces. The good news about the low power, there's maybe 2 or 3 companies in the entire world that have specialized over the last couple decades in perfecting how they manufacture, how they design and process low power OCXOs. A lot of the technology involves the direct heating in the crystal can, the direct heating of the crystal resonator area. Not necessarily metal deposit on the crystal blank, but a ceramic heated surface that's heating the crystal up through its crystal mounts. So we have very strong in low power OCXOs in dip package size or in 20 by 20 modules where there's a low power circuit inside the 20 by 20 package. We can do a lot of different types of low power designs. And at good phase noise and at fairly high frequencies, up to as much as 250 megahertz. So you might find that there are some applications, at first the customer might say, I need a TCXO at 100 megahertz. And right away you want to ask them, what is your total power budget? What is your total power allocation you can give to the precision oscillator reference? If they tell you 0.2 or 0.3 watts or 0.5 watts, then you might want to promote a low power OCXO at 100 megahertz over a 100 megahertz TCXO. You're going to get better stability, 10, 20, 30, 50 parts per billion versus 1 or 2 parts per million for a 100 megahertz low noise TCXO. So better phase noise with an OCXO, better stability with an OCXO. And in fact, cost-wise, you're going to be roughly equivalent or even better for cost using a low-power OCXO versus a 100 megahertz, what they consider high-frequency TCXO, depending on the application. So that, again, is a niche that has various levels of demand, and we can satisfy those. Thank you.